Okay, next problem. A rectangular plot of land is to be fenced in using two kinds of fencing. Opposite sides will use heavy-duty fencing, selling for $3 a foot, while the remaining two sides will use standard fencing, selling for $2 a foot. What are the dimensions of the rectangle of greatest area that can be fenced at a cost of $6,000? So we read the problem. Step 2, draw a picture. A rectangle again. We'll use some color. So in blue we have standard fencing. In red we'll have the heavy-duty fencing. So there's kind of the picture. 3, the constraint. All right, so I'm going to give myself more room on the constraint, so we'll do the constraint down here. 3, the constraint. So when I read it, the constraint's at the very end, that the cost should be $6,000. We had to decide what that means mathematically. So when I read it again, it says two opposite sides will use heavy-duty fencing, selling for $3 a foot, while the remaining two sides will use standard fencing, selling for $2 a foot. And so the cost is really going to be split up into how much standard fencing I buy plus how much heavy-duty fencing I buy. So it really is all about the amounts of standard and heavy-duty. So let's introduce some variables. So my standard fencing I'm going to call X. My heavy-duty fencing is going to call it Y. And remember, you've got to tell your reader what these things mean. If you do not tell your reader what your variables mean, you've told your reader nothing. You've got to tell me. Now, thinking about the cost. So in general, we got heavy and standard. And so in general, it's going to be the cost of the standard plus the cost of the heavy is going to be $6,000. So then thinking about it some more, how we do cost. And all of you intrinsically know how to do this. I don't know, do Little Caesars, I don't know if pizza still costs $5 at Little Caesars or not, but they used to. So the cost of a Little Caesars pizza is $5. You buy 10 of them, your cost is 10 times 5, the amount times the price. Same thing here. The cost of my standard will be the amount of the standard fencing very specifically times the cost of standard. And then the amount of heavy but we're going to put price here. Price of standard. I like that word better. Times price of heavy. And that has to be 6,000. And now we're going to put some X's and Y's here. So I go and look at the picture. The amount of my standard fencing in blue, X plus X, 2X. And then they told me up in the top of the problem, standard fencing costs $2 a foot. The amount of the heavy, Y and Y, 2Y. And the price of the heavy, I go up there, was $3 a foot times 3. That's going to be 6,000. And so 4x plus 6y equals 6,000. Solve for one of those variables. Again, it doesn't matter which variable you solve for. Just solve for whichever one you think is going to be easiest. And so I get y equals 1,000 minus 2/3 x. And there's my constraint. Now in this problem, it's the constraint that was going to take the most effort to figure out. But please note that I didn't just start writing down x's and y's. I thought about each little thing. Cost equals 6,000. They told me that. Then what did that mean in terms of this problem? Well, the cost of the standard plus the cost of the heavy. Then I figured each one of those things out. That you don't start with x's and y's. Start with words and thinking about what the situation means. So there's step 3. Step 4. We wanted to maximize the area. And remember, our picture looked like this. So area will be x times y, but we need one variable. So I will use that y is 1,000 minus 2/3 x. So area equals x times y. Area equals x times 1,000 minus 2/3 x. And so area equals 1,000x minus 2/3 x squared, 4x on. Again, like I've said on the other two problems, these are going to be generally situations where negative numbers just don't make sense. X in this case is this horizontal distance here, so negative numbers don't make sense. Mathematically, there's no problem putting 0 into this function, so I'll use a square bracket. But if you use an open parenthesis, I don't care that much. I just don't. But mathematically, the way the choice is usually made is if 0 works in the function, include 0. Then that second number. The first number comes from your primary variable. The second one comes from keeping y positive. Keep y positive. Or whatever your secondary variable happens to be. So in this case, y greater than or equal to 0. 1,000 minus 2/3 x greater than or equal to 0. So that's 3,000 minus 2x greater than or equal to 0. Negative 2x greater than negative 3,000. X less than or equal to 1,500. And there's the upper range, upper limit. Always starts at 0. That represents your primary variable. The secondary variable determines that second number and about keeping that secondary variable positive. So there's step 4. And if you can get to this point, you can finish the problem. It's getting to this point that is the hard part. It's getting to this point where each problem is different. But then step 5, I want my derivative. And so a prime is going to be 1,000 minus 4/3 x. Critical number. Set that derivative equal to 0. Let's multiply everybody by 3. So I get 3,000 minus 4x equals 0. Negative 4x equals negative 3,000. X equals 750. And again, that's where we suspect the answer is. And the way they write every single Calculus 1 textbook, that is going to lead to the answer. But all we know is that that's a critical number. Could be a max, or min, or nothing. Must verify. And in this case, we wanted, I forget what we wanted. We wanted a maximum. It said greatest area. So we have to do step 6. If you forget step 6, you will lose points. So 6, verify max status on 0 to 150. And again, I'm not going to stress much, oh, you didn't use the best method to verify the status. I'm just looking for an attempt here. But on a closed interval, your best way is use the absolute max min procedure. Recall the original function was 1000x minus 2/3 x squared. And so I want to find a of 0, a of 750, a of 1500. That was the absolute max min procedure. You found your derivative, found your critical number, or numbers as the case may be, here just number. And then you took those values, the endpoints, the critical number, or numbers, and you plugged into the original function. The way this works in Calculus 1, these endpoints, those are always going to lead you back to 0 because that's how we set those things up. But if you want to plug them into the original function, you can. And when you plug 750 into the original function, let's see if we can get my calculator to do this for me. It keeps turning itself off because it wants new batteries. 1000 times 750 minus 2/3 times 750 squared. Yep, that looks right. You get 375,000. That clearly is the maximum. You got 0, 0, and 375,000. That clearly is the maximum. So then answer the question. Step 7, and the final step, what are the dimensions? So the picture looked like this. The standard was X. The heavy was Y. Standard fencing, heavy duty fencing. And so standard was the 750. The heavy duty was Y, and Y was equal to 1000 minus 2/3 x, so 1000 minus 2/3 times 750, which is 1000 minus 2 times, I should be able to do that in my head, but I can't. 750 divided by 3 is 250, and that's going to be 500. So we want 750 feet of standard fencing and 500 feet of heavy-duty fencing. And that will conclude this video.